All right, we're going to start over. So I'll just repeat what I just said. This is called the difference of squares, what we have right here, right? And when we have x squared minus 49, we know what to do with it. Let's go figure out what does it mean to do p plus q times p plus q. So when you do p plus q times itself, you will end up with p squared. What will you also get? Plus pq, right? Okay, that's the first thing, p times everything. Then we do, now q times everything, right? So we say q times p. Oh, there'd be another one of these. And then the last thing we do is q times q, which is q squared. Is it then true that you would end up with, if I write it down here, p squared plus 2pq plus q squared? Do you see it? Is that true? Mm-hmm. Guess what this one would be? P squared minus 2pq. Oh, mercy. Plus q squared. Do you agree? If we work that on out, that's what would happen. So we're trying to get you there's a quick thing to do here. When you have this first term is squared and the last term is squared, and then see the PQ together and it's doubled and dropped in the middle. Do you remember this going on? Square the first, square the last, times them together, double it, drop it in the middle. Remember that conversation? So when you see this going on, we can quickly factor it. But let's write down. The first term in the trinomial is a square of the first term in the binomial. The last term in the trinomial, this q squared sitting out here, is the square of the last term in the binomial, right? We took q and we squared it. Then the middle term is twice the product of the first and last. That's where that multiply them together, double it, and drop it in the middle. Remember that conversation? We did that a while ago. All right. When that occurs, this is a perfectly square trinomial. And it says in a perfectly square trinomial, if we're reading along right here, in a perfectly square trinomial, x squared plus 10x plus 25. Notice that one. The first and the last terms must be perfect squares. Okay, notice the x squared and the 25. And the middle term must be twice the product of the square roots of them. So think about x and think about 5. Times them together, double it, drop it in the middle. Does that occur? That's where they get the 10 from. So that is called a perfectly square trinomial. Okay, so let's go talk about whether these would match that or not. A squared plus 4a plus 4. Let's talk about this first one right here. Let's see if it works for all of those things. Is the first and last terms perfect squares? So if I took the a, which is the square root from here, and the 2, which is the square root from the 4, and I times those together, what would you have? No, times it together. 2 times a is 2a. Double it and drop it in the middle. Do I get that term? Yes. So this is a yes on it.
Why don't you get 4a squared?
Because 2a and another 2a, when you're combining them together, is just 4a's. Right? Because adding is like adding elephants or adding apples or adding the crops together, right? When you add, you just combine. You just go combine. Okay, let's talk about letter B. Is this one a perfectly square trinomial? No. What was your first clue? 6. The 6 is not a perfect square, so no. Okay, let's talk about C. Is C a perfectly square trinomial? Does it appear to start that way? Is there a square root of 4x squared? Write it down. What is it? 2x. Is there a square root of 81? 9. Oh. Now, if you times those together, what will you have? 18x. And if you had another 18x to throw in the pile, what would you have? 36 x's. Does it work? Yes. Let's go talk about D. Does it appear to be a yes? Does this appear to be a perfectly square trinomial? Let's go check it out. So we have a y here. This is a perfect square. What is the square root of a negative 16? Oh, this is a no. Why is that a no? Say it louder, somebody. You're figuring it out. I'll let you just mumble with that one. You kind of all just mumbled and whatever. Malachi, tell us again.
Because they both have to be the same, so they get negative 16 have to be positive 4 and negative 4.
Right. There is no square root of a negative 16. Because a negative 4 times negative 4 is positive.
Oh, I see.
You see? And a negative 4 times a positive 4, well, that's not a perfect square then, right? So that's a no. So that's a huge hint right there that this sign on the end has to be positive. If it's not positive, you have a no. Okay? All right. Let's keep working on them. Perfectly square trinomials. Fill in the blank so that each of the following is a perfect square trinomial. All right. So they've set us up pretty good. Square root of the first one, x. Square root of 100, 10. Times them together, 10x. And then another 10x, 20x. That's the number that goes in the spot. Okay, try again. Next. Okay, so I'm going to have an x and a 10. Does it matter if this sign is negative? No, it doesn't matter. So times the 10x together, double it with 20x. Good. Needs an x on it. Okay, C. What are you going with here? So I'm going to talk about the square root of this, which is 5x. Square root of 36, 6. Times them together, 30x. And another 30x, 60x. Good. You've now created a perfectly square trinomial. Last one. Ooh, a little harder. Who can do it?
Where do you get the other 30x from?
Because to be a perfectly square trinomial,
Oh, yeah.
there has to be two of them in the middle. There will always be those two terms. I'm going to show you some more in just a minute. Okay. Square root of this, 3m. Shucks. I don't know what this is.
16.
You think the number here is a 16?
Yeah, I think.
Because then this would be a 4. And then that's 12 times 2, right? Is 24. That'll work.
You just times 4 by 2. Like,
Well, you always take the 4 times the 3m, that's times, which is 12, and then you double it, right? So you times it by 2. Yeah, that's a tricky one. Okay.
Oh, yeah, that's all.
All right. Class example 3. What if they say to factor this? Well, here's the reason we're learning this. This is what Victor's question was about a little bit. If you have a perfectly square trinomial, factoring is easy. So is this a perfectly square trinomial? So this has a square root of 7x. This has a square root of 1. Times those together, 7x. Times it by 2 or take another 7x, you get 14. Yeah, this works. Okay, so guess what this is going to be when you factor it? 7x and a 1 and the sign of the middle term. And then you're going to square that. That's how quickly you can factor a perfectly square trinomial. See it? Now, that is a shortcut. If you don't know what to do, if you don't recognize that it's a perfectly, can you just do this old way? Yes. Okay, I need something. Oh, it looks like 7x would maybe work. Okay, let's try 7x. Oh, factors of 1, 1 and 1. Huh, will that work? Well, maybe I should go check it out. Let me go see. Oh, Nelly. Let me go test it out and see if it works. So you go over here somewhere and you do a little check box, right? Okay, I'm going to call this my check. And I say 7x times 7x. Yeah, so far so good. Oh, yeah, 7x. And your 1. See it? Now, Victor, do you see how there turned out to be 2 7x's?
Yeah.
A 7x will occur twice. Always. And you go, this works. So the deal is, what I'm trying to teach you today is a shortcut to this information. And the shortcut is this. Rather than doing the factoring the whole long way like we did before, okay, it is possible to get straight from this original line to this line, to the 7x minus 1, right here. if it's a perfectly square trinomial. Okay, it doesn't like me at all. I'll go back over there. Okay, let's do letter B. Is it a perfectly square trinomial? Have you checked it all out? Have you thought about it? So you have a 4 and a 5x, which is 20. Double it is 40. Yes, it works. So you know how you factor this? 4 plus 5x big squared. That's how quickly you can factor that if it's a perfectly square trinomial. Do you want to see if that works? Write it out again. Go work on it, right? It will work. Okay, how about letter C? Is that a perfectly square trinomial? Yeah, I don't like that one very much, do you? How come? Because the 1/9. Well, is there a square root of 1/9? It's 1/3. So let's just write this down. Let's just double check. 1/3 A. Is there a square root of 9B? 3B. Sorry, 9B squared. Okay, what would happen if you took 1/3 A and you multiplied it by 3B? What would you end up with? What's 1/3 times 3? Oh, you'd end up with 1AB. Double it. 2AB. Hey, it works. This is a perfectly square trinomial. So do you know how you factor a perfectly square trinomial? You take the square root of the first, the square root of the last, and the sign of the middle term. Don't forget to square the bracket. I'll say it one more time for you, Cal. Listen. If it's a perfectly square trinomial, to factor it, you take the square root of the first, the square root of the last, and the sign of the middle term. It'll always be this negative sign. Whatever that middle term happens to be, that sign, that's the sign that'll go in the middle of your binomial. Don't forget to square it. Okay. Class example 4, let's factor this. Is it a perfectly square trinomial? No. I don't know why it's in this section. So let's just factor it normal way. Ready? What's first? A squared and A squared. Agreed? And how do I get 14? 7 and 2 and minus 7 plus 2. All in favor? Okay, next, B. I don't know why these are in the, I think they're in this section because it's the higher power, but no big deal. Okay, go here. How do you want to start? X squared and X squared. How do you want to play the 5? 1 and 5 is only one way. This is tripping out today. So 1 and 5. You're saying a -1 and a +5. Agreed? Okay, right here. How many of you would quit at this point unless the teacher was standing there looking at you saying, excuse me, right? Several of you would probably say, woohoo, good, I'm done, I quit. Next question. But since the teacher's staring at you and looking at you like, you should factor further, how many of you can figure out why am I telling you basically that you can factor further? Which part of this can factor further? Malachi? What, Ben?
So 7 times 2, right? And then is 9, right? If you add your 72.
Okay, wait. I'm on B though, Ben. I'm on B.
Oh.
That's okay. That's all right. I thought you were going on. Yeah. You were going, he was going to the next question. That's okay. I knew what he was thinking about. You're thinking about the next one. Hold your thoughts. Okay, I'm on part B. I want to know, how can you go further? Why can you factor further? Gabe thinks he knows. Because there's an X squared. I didn't factor further on part A when there was an A squared. True. Think. Look, think. How come I can factor further on part B? Okay. The very first thing I said when I opened this lesson was I gave you an example of x squared minus 49, and I said factor it. And what is x squared minus 49? What kind of thing do we call that? Tell me what it's called first.
Perfect. Or difference.
The difference of two squares.
Oh, I wanted the square.
Oh, one is a perfect square.
Oh.
Thank you, Kale.
Said it wrong.
So if one is a perfect square, if you just look at this bracket, if that was the only one you had in the question, and I said factor it, what would you do with it? Would you go x minus 1 and x plus 1? Yeah. And then you'd copy down the x squared plus 5 because it is not able to be factored further. That's it. But you must always look inside your brackets. Write down. That question on the quiz that I said pull out the 2, make sure you're checking. Is what I have in my bracket, is that factored as far as it can go? Always look to factor further. All right. Now are you done? Yes. Part C. All right, Ben, we're on it. What are you going to do with this? X cubed, yep, x cubed, and then?
And then 7 and 2.
Uh-huh. And what will the signs be?
Oh, both positive?
How do you,
Oh, both negative.
You got a 09.
how do you get x cubed?
Okay, well, what would you times by itself to get x to the 6?
X cubed.
X cubed times x cubed. Okay, let's go back. If you're multiplying x cubed times x cubed, tell me the rule. If you're multiplying and the bases are the same, keep the base and add the exponents. Right? See, it all comes back. Okay. The other way I knew that is because the middle term had to be an x cubed, so I went with x cubed. Okay. Good. Turn the page. We good on it? Factor completely. There's nothing else to learn. Factor completely. Okay.
Why don't you put like the 8 on the outside? or something?
Let's do question 5 first. Up here.
Oh, okay.
That's okay. Let's do up there. All right. So how are we going to start this thing? Could be hard. 4 and 6 is kind of hard because they have lots of factors. What are you going to start with? We'll just try.
2x squared.
2x squared, I would try there too. 2x squared and 2x squared, because those will multiply together to give you a 4x to the 4th. Okay. What do you want to try for 6? 3 and 2?
Yeah.
Where are you going to put the 2? Where are you going to put the 2?
Doesn't matter.
Oh! Can I put the 2 anywhere?
No.
No.
No, why can't I put the 2 anywhere? Then there'd be a common factor, and there were no. Okay, so guess what? 2 and 3 don't work. Try again.
Let's do 6 and 1.
Okay, let's do 6 and 1. Where can you put the 6?
On the other side.
Doesn't matter. Wait, you can't.
Can I put a 6 in with a 2?
No.
No. So neither 6 and 1 nor 3 and 2 work. So what does that tell you?
It can't. It's not possible.
It is.
Would you change it from 2x to 4x?
What it tells you is that the 2 and 2 is wrong. Perhaps you should try 4 and 1 before you say it's not possible. Does 4x squared times x squared give you 4x to the 4th? Yes. I'm not going to put the 1 there. I find it cumbersome. Okay. So far, so good. Now, let's try with your 6. What do you want to try? 3 and 2. Where does the 2 have to go? 2 has to go in the very last bracket. It can't go in with a 4, and then you put your 3. Okay, now play the game with me. Play the game. Don't write anything else down. Can you see? Do this. Work it out in your head. Okay, you're multiplying the first term times everything. Is it going to work?
Yeah, plus
We think it's going to?
positive 2 and then.
Okay, Ashley thinks this is going to work. Why do you think? Let's go try. Here we go. Ashley, do not listen to them. They're like crazy over there. Okay, I'm going to get 4x to the 4. I'm going to get plus 8x squared minus 3x squared minus 6. What's the problem, boys?
It's plus or less.
Other way?
Yeah.
Okay, so she was close.
Almost there.
So make this a positive and this a negative. Now does it work? Because then your 3 is positive and your 8 is negative, and that will give you a negative 5x squared. Yeah, yeah? Okay, good. Can you factor further?
Yes.
Where?
First bracket.
The first bracket. What would you do with the first bracket?
Square root. X squared. No. It's
So you're going to go like this, you mean? Keep this one the way it is, and you would do something with this first bracket? What would you try to do?
2x.
Okay. Don't write this down. We're just going to let him mess around with it. 2x and then 3 and 1? Okay, let's try. Look what happens, Gabe. As soon as you do this, you get a middle term.
Oh.
Okay.
And there is no middle term in that bracket. So you're done. But you know what? Trying, why wouldn't you try? Try it out. Check it out. No, it doesn't go any further. But it was worth trying. Okay, next question. Part B. Ready? We're going to get on with this. Wow, this is taking a long time. Okay, B.
Y5. We're both right.
Y5 for both brackets. Sounds good. And what are you going to choose for the other term? The 12?
2 and 6.
2 and 6. I think that'll work. A positive 6 and a negative 2. Yeah, yeah? We all good there? Can you go further? The only time you could ever go further is if you had a difference of squares. Do you have a difference of squares? No, you have a difference, but they're not squares. Okay, question C. What do you want to start with?
2. Oh, wait, no.
Yeah. 2AB and AB. That's the only way you can get 2AB squared. It's only one way. Okay, 99. What's the first thing? 11 and 9 is the first thing that pops into my head too. Okay, I don't know where to put 11 and 9. I'm just going to guess. Anybody want to tell me where to put the 11? First bracket, second bracket?
11 first.
11 first? Okay, let's try. All right, I got to go get my pen down here. I got to check it out. So I'm going to write a check here so I remember this is not the answer. Okay, so I get 2AB squared. A squared, B squared. I get 18, and then I get 11 and 99. Do these two work? 18 and 11, can that get you 31? Okay, what if I just switch the 9 and the 11 around? Let's just change these two. What if you put the 9 here and the 11 here? Then what will happen? You'll get 22 from this big one and 9 from here. Can that give you 31? Yes, if they're both negative. Good. Okay? Good. We're going to go to the last class example. Did you see the question on here? What does it say? Your title that I just skipped? More complex difference of squares. There's nothing new today. Everything I've taught you today, you already knew how to do. We're just practicing. Okay, so give me, which one? I'm going to do 2 of these. Which ones do you want to do? C. Let's start with C. What do you see on C?
P.
2. Wait.
A 2. What about the 2, Abby? What about it?
Oh, take out the common.
Okay, take out the common factor. Yeah, 2. 2 is a common factor. Okay.
Yeah.
Is there anything else common besides the 2? A P is common? Okay, so I'm in the first step. I'm leaving myself 1 bracket in step 1. What would I have left? P4 Q4 minus 81 T4. Right? Okay, there you go. There's step 1. Copy down your 2P, and here we go. What do we have now? Can I go further?
Yeah.
What's it called?
Different.
Difference of squares. So here I go. I go P squared Q squared in both first slots. And what's my last term? 9T squared. One's a plus and one's a minus. And you have factored fully at this point. There's no, I haven't. No, I haven't. Which one can go again?
We'll fly.
P squared Q squared minus 9T squared. Isn't that the difference of two squares again? Yeah. Okay, always look at the negative one and double check yourself. The positive can never go again, but the negative can. So you have to copy this all down. 2P. P squared Q squared plus 9T squared. Don't do the plus one. The plus one cannot go again, but the negative can.
Can't you like rip out the heart or something?
No, you can't rip out a heart.
It's like the same though, except one's negative.
Yeah, but they're not. It's exactly, but they're not the same. To rip out the heart, they have to be exactly the same. Okay, then how would I go factor this red one further? How could I do that further? PQ. And then yeah, so minus 3T and plus 3T. Good. So be sure to double check. Can you factor further? By the time you get to the binomials, when we have the two terms, all you have to check is the negative one. Okay? If there's nothing common, check the negative one and see if it can go. Okay, I'm going to quit there. You have 20 minutes, not too long, but you've got 20 minutes. Work on your homework.